Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about BSNL NB IoT. It became the world's first satellite network, so we'll talk about that. Now, what we are talking about? We are talking about a quote-unquote backbone for IoT devices, aka Internet of Things devices. Now, be mindful, the NB in front is classified as narrowband. Now, narrowband is quote-unquote vague term because it can apply in any spectrum. So mathematically, if you take the spectrum completely whole and if the signal strength is basically much higher than the width of it, it will technically call as narrowband. So it's more of a mathematical term rather it's like calling something long. So narrowband is the whole point. It will look like a point, and most equipment generally utilize a broadband, or sometimes they utilize whole spectrum, which we call ultra wideband. So that's what we are talking about. NB is for narrowband and IoT is for Internet of Things devices. Now be mindful, the whole unique part of it, like the first time in the planet is because it's utilizing a satellite network. Now this satellite network is provided by BSNL because BSNL already had a satellite internet services geostationary based. Now it does work. It is been a kind of a very unique backbone for Indian ATMs across the rural area. It's a real thing. We utilize it. It's kind of like a fundamental backbone at this point in time. So it has one core advantage for Indians is like all India coverage. Now be mindful, geostationary satellite does have a very kind of a quote-unquote wide projection area, so it does cover much more than India. It's just like it's absolutely certain if you have access to sky, this puppy is like I got you, man. It's like complete coverage. You do not have to think about coverage in India. So that's the whole selling point of this device. Now it will over time will have worldwide coverage also. Now let's talk about technology. Now technology wise, the technology is provided by a company known as Skylo. Now what they are providing is basically they are giving you a box, this white box. Now this white box is quote unquote two-way communication system, because think of it this way, like satellite communication to geostationary, we have been doing it. That's what we call satellite TV. Basically it does work, and it's a freaking giant bandwidth coming from satellite. It does work. It's just like it's not two-way, it's one-way. Like it would be like equivalent of like having giant coming from one side and like little thing going from another side. So reality is it's a real thing. It does work, but it does provide you two-way system plus location data also, because this puppy has a lot of advanced chip, which includes accelerometer, things of that nature. It also has G3 chips. What does that mean? G3 chips are basically navigational systems that utilize three constellations like GPS, GLONASS and Galileo. Benefit of that is like no matter where you are, even like almost on a turn, the likelihood you will receive a signal is very high. And the fact, especially in cities or areas where you have a lot of foliage, because satellites, you have to achieve like 5 satellites to get a confirmed log. So GPS is not good enough for that. Again, GLONASS is also not good enough for that. Galileo itself is also not good enough. But if you mix all of them, you will always have satellite coverage. So that's the whole point. And modern mobile phones, all of them have like G3 chips or sometimes G4 chips, where they are also utilizing another system from China's global positioning system. So you are getting a two-way data transmission and accurate location data within 3 meter. Like it's not meant for like absolutely precise equipment, but it's like, dude, you can be damn sure this is where your equipment is. Then the pricing is around $100 to 8,000 rupees, like in Indian context, and per month supposed to be $1 or 100 rupees per month. Now be mindful, this could change at this point in time. It's very early on, so I cannot vouch for this, so to say. And data rate is up to 20 kbps. Now we're like, wait a minute, it's a satellite internet, why the heck it's so small? It's not meant for equipments. That's why I specified IoT devices. Most IoT devices, if you remove security cameras, they do not need so much equipment. For example, IoT devices generally say sensors. What does sensors do? Like let's say a current sensor, it's barely gonna send you one data point. It's like, okay, this value. Now imagine you have multiple sensors connected in a household. You're creating a spreadsheet. How big is a spreadsheet? Like again, think of it in like per second wise. Like can you fit that data inside a pipe when you are running at 20 kbps? Easily. So that's the whole point of it. It's not meant for like okay, I'm gonna do 4K video streaming. That puppy is reserved for Starlink system. This is completely different. That's why NB and IoT is very specific to this puppy. Now it's utilizing L-band. L-band is from 1 gigahertz to 2 gigahertz. Now you may be like, why utilize this band? Well, the lower your band, the higher range you get, but lower bandwidth you get. So for example, you can easily do this testing in your Wi-Fi router. Most likely you have a dual band Wi-Fi router which has 2.5 gigahertz and 5 gigahertz. You can test this puppy out. Like if you go to 5 gigahertz, your speed goes YOLO, but your range goes no. So at that point in time, you will realize that 2.5 gigahertz better. What's better than 2.5 gigahertz? Even lower spectrum. So lower the frequency, the higher the range you get. Now given this puppy has to talk to a geostationary satellite, which is around 30,000 kilometers, more than that away. So reality is, to communicate to that far, you really want to have good signal strength. Now this is a heavy equipment. Now this equipment supposed to be running 24 into 7 kind of deal. So if you have your assets like a container ship, or let's say something much more demanding, let's say a truck, it has to go there. Like you have to figure out the power requirement. So this puppy, if it's communicating upwards 24 into 7, it will consume around 20 watts per hour, so to say. So if you are like only receiving data most of the time, and sometimes you have to send, you don't need too much power for running this. But worst case scenario is 20 watts of system power, so to say. Now this is just a box, it's going to communicate. Now they built with a lot of basically survey from the industry, so it has Wi-Fi, so it can act as a Wi-Fi spot anywhere in the planet. Now if done correctly, utilizing their app, you can have quote unquote communication to internet and like have at least messaging service going on. But good luck with that. Like again, it's not meant for that. It can be done, it's just not meant for that. And it also has Bluetooth low energy. Now Bluetooth low energy is specifically there. Think of this way, there are many companies that make smart sensors nowadays. Basically those sensors are like quote unquote becoming a backbone of industry. So think of it this way, you have giant motors like ABB giant motor, it's like 1 megawatt power. Now those motor will have it's so expensive that you want to keep sure that hey, this motor is not something I can just replace, so I would want to take care of it. So ABB will give you a package. That package will be sensors, like it will have accelerometer, thermal sensors, and all sort of jazz, and that data would be transmitted over Bluetooth low energy. This puppy can receive that and directly allow it to transmit to ABB itself. And again, imagine it this way, you are working in a place where it's a lot of electrical noise is there. For example, you're dealing with transformers, you're dealing with plasma arcs or something like that. You don't want to rely on wireless system. That does make sense. You can utilize RS485. It's an industrial kind of standard. You can rely on that, or you can go something low. You can go to UART and I2C. So ask your friends who are dealing with Arduino, they know this sort of standard. It's also used in other equipments. For example, your car, many times your steering will have I2C buttons and all that. So those button signal, they are going through I2C kind of bandwidth. So lot of equipment like communication ability is directly inbuilt into this. So if you want to run this puppy on a truck, you can directly hardwire this to, let's say, OBD2 port, and this puppy can run directly. So if the truck engine starts, this is like, I got the power, I'm running, I'm on, everything is going on. You have location data, and it has enough bandwidth, so you can transmit, let's say, engine RPM, fuel consumption, all that jazz, and other data also. So if you want to like also link with the driver's mobile phone, it can do that, because it can create its own Wi-Fi hotspot or some other kind of sensor you may have, Bluetooth sensor, you can utilize that also. So that's the whole point of it. That's the whole tech that you will buy. That's on your end, customer end, so to say. Now, what was the use of something this complicated? The reality is, remote locations have the worst kind of connectivity anywhere. So, for example, I was in Bangalore for 6 years. Now, in those locations, the only issue was, the reason why I was not getting YOLO amount of connections was because I did not have a lot of money. So, if I did not have a lot of money, I only had like 2 or 3 fiber connections. If I had a lot of money, I could have even paid Reliance. That time they were giving like 8 Mbps very early on, but raw unlimited, like go YOLO on it. So I could not get that kind of connection, so I started like very early on, like 30 GB per month, but over time it started to go. Remote location, now that's Bangalore. Now in my small town, things have improved after that a while, and I can access easily 1 Gbps connection in my hometown if I want to, fiber connection. Now what about a village area? Good luck with that. Good luck getting even a proper dial-up reliable connection. Good luck with that. So in remote locations, you are stuck. So if you have a lot of assets, basically sensors that you want to connect to internet, good luck with that. If you want to collect all the data, you may be better off literally creating a whole radio server directly for yourself. Like you literally like, okay, my head office is here, I'm gonna build a tower, 100 from my office, another 100, another 100. Like that would be more quote unquote easy. So remote area is flat out of touch. Another aspect is mobile connection, because while it is true I can get YOLO amount of connection in my home, yeah, the moment I have to rely on 4G connection, yeah, good luck with that. And if I'm driving in a car, good luck with that. Now imagine this way, like you're talking about freight, you're talking about container ships, those things will especially those containers, they will go everywhere. You not have mobile, if you don't have anything that can work in mobile situation, it will simply not work. It has to work while moving. So the way this puppy achieves that, it has quote unquote one step below phase shift technology, because it's talking to geostationary, and geostationary satellite is normal, but the object is moving. It has like a quote unquote satellite antenna pattern like this, and it will select sub satellite sub antennas inside that. It's like, okay, this antenna is better right now, utilize this antenna. Okay, this antenna, it's not a phase shift, it's not aiming, it's not like Stardish. That's the reason it's so cheap and so low power in consumption wise, but it can easily quote unquote select the best antenna that will work. So that's the whole point. So if you have a container ship or you want to monitor your assets, especially delivery wise, awesome. Then tracking or monitor asset, because it has so many subcategories, like it can compile a lot of data. You may think 20 kbps is low. That's simply because we utilize a lot of multimedia. 20 kbps just for sensor data, that's like GG. That's GG amount of, like, that's almost a big factory. All every single sensor data can be compiled into that. So, and if you do a lot of compression, you can easily get it down to 8 kbps or even 10 kbps. So it is doable. Now another aspect is remote deployment of smart sensors directly can be done. Think of this way: when you're talking about motors that are huge, as in like 1 megawatt, 2 megawatt, or 10 megawatt, at that point of time, if you're going to say I want to add $100 more to it just so I can make sure I can like, let's say ABB or General Electric or Siemens, they want to directly monitor your equipment. So they're like, dude, I know for a fact that this motor is about to go bad. I'm gonna call the individual, the basically whoever is responsible for this. I'm gonna call them as like, dude, I'm scheduling a servicing for that because I know it's gonna go back, and then you're gonna curse us. So that can be done, and you can do it anywhere, all over the basically Indian place, and over time all over the planet. Remote comlink, because it does have the ability to where you can have a like quote unquote chat service. So if you have some individual that's doing a remote study with some forest area where it's like no communication, at that point in time even a text communication is more than good enough. If you don't have anything else, this will work, and it's much cheaper than a satellite phone. So that's the whole idea of this. Now, what are the benefits? Those are the users. Like, do you get something extra, quote unquote? Well, thankfully, yes. Now, if you look at the business data points and the website itself, they will talk about a lot about fishery. Now, the reason is, practically speaking, you can't have mobile towers in a sea, so to say. Even if you just only want to cover, let's say, 100 kilometers from India's actual border, good luck with that. No mobile tower has that kind of coverage, but satellite does. So safety for fishermen is very important, and thankfully it has already been tested. There was like multiple ships utilizing this technology, and they had a SOS beacon. So if they started to go overboard, or like, boat started to sink, a person triggered the system, that alert directly went to Coast Guard. Coast Guard alerted the boat nearest to it because they had the accurate location. They're like, dude, go there are people sinking there. Like, life saved. It's an actual thing, like actual safety measurement, and it's not a very expensive equipment. It's not something ludicrously complicated. It's a simple thing, and it can also do. That's why the fact that it has two-way communication is important. It's not just like it's gonna yell, hey, there is tornado here, tornado, I'm saying basically tsunami is coming, please come to port, or some other equations could also happen. So at that point in time, that two-way communication is very important. Early warning from remote location. Let's say you have sensors at like some remote places. Hey, if this area is flooding because of heavy rain, you know for a fact that over time it's going to flood into the main city, and you want time to prepare. You can have remote sensor. Or if you forest fire, if they are small, you can easily tell. That's like minor issue. But if it becomes big enough that everybody knows it, yeah, that's too late for it to be handled properly. So remote sensors, awesome for that. Now, accurate location, location of an incident is also priceless. Think of it this way: Indian Railway has a lot of people moving from point A to point B. Now these trains go through basically all over India. So if something bad happens, I hope it never happens, but it does happen over time to time. Let's say a train derailment happens, or something, train just like engine malfunction is stuck. Now, if it's happened in quote unquote middle of nowhere, this system can still trigger the alert, and still like the driver will have a simple button, SOS button, and it will like literally trigger an alert system wide. Whole railway will know, okay, there is a train that's missing, that's supposed to be here, it's not here, where the heck it is. It will get exact location, and then some, let's say, recovery engine can easily go there and recover this puppy. Has happened enough times. So reality is, and if something bad happens, let's say accident wise, and if you know the exact location, you can literally look up the map. It's like, which is the hospital nearest to it, and you can literally call them up, hey, before the even as a prepare your emergency ward. Because if you save that first 20-30 minutes of time, and if hospitals are like, okay, we are ready, not like, okay, first ambulance is coming, no, I'm ready for ambulance, we got this, everything is streamlined, you will save a lot of lives. So it's fundamental safety benefit. And reality is, nobody's gonna pay for safety devices. It's simply the fact is, it will optimize industry and improvements, and benefit of that makes your factories run for much longer without the downtime, and it allows you to like basically spend less money and get more work done if you are efficient with it. So that's why industry is adopting this kind of technology, and there was a very serious demand for this kind of system in India, and BSNL went YOLO on it. It's like, okay, satellite baby, direct. So there are some serious benefits. It's not just a cool tech, it's actually beneficial for industry. So this was my presentation on quote unquote narrow band Internet of Things kind of devices. I hope you learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.